Good on this, please. Let us discuss the results. So, can someone try to sum up the results? What are the effects of these two parameters, the dynamic parameters, epsilon and t? So epsilon, the parameter which controls the increase of price, and t, the time of decrease of price. Can someone try to make a guess? Or did you reach this analytical equilibrium in every case? No, not all the time. Not for all values of parameters you reach the analytical equilibrium. So what happens when you don't reach it? What's the problem?
Empties.
Yeah, there are empty cells. So why is no one moving in those cells? Because from this dynamics proposes all the moves are considered. You are choosing at every time step one agent and a cell, so you are proposing on average all the possible moves. So why are some moves not done? Why is no one moving in those cells which stay white?
The price is too high at some point. At
Yeah.
the end of the iteration.
Yeah, the price is too high, and then why isn't it decreasing?
Stop moving.
Well, actually, the decrease is this parameter. So it's not decreasing fast enough, maybe. So this parameter is too high, and then the price is not decreasing fast enough. So you have to tune those parameters. If you want to reach this analytical equilibrium, you have to tune the scale at which price increase and the scale at which they decrease, so that there is really this matching between supply and demand, if you want. Okay. Well, and this, if you look closely, this happens mostly for low values of the big parameter. So you have to make slow increases in prices to manage to reach a nice looking equilibrium close to the mathematical results. Okay. So this whole simulation shows you maybe a not very usual use of simulations in geography, but it's one which is quite usual in other disciplines, particularly in hard sciences like math, physics, etc. So where you do simulations which reach an analytical model, and they allow you to find results when analytics are too difficult. When you can't do the math, you try to do the simulations. But the simulations are supposed to be rigorous enough that they give you the same results the math would give you if you manage to do the math. Is this clear? Yeah? So it's kind of a help if the math is too difficult, then you do the simulations. And it's really a usual way to see simulations in hard sciences, but not so much in geography, for instance. Okay? Yes?
Do empty spaces appear too in mathematics modelization?
In this the standard model which we presented so far, there's no empty space. The whole space is used for housing until the urban fringe, and after that it's completely used for agriculture. And in all the areas which are used for agriculture, the rent is the agricultural rent and nothing else.
I was wondering if in the city itself there were such halls like in the model that...
in real cities, you mean?
No, in the space as thought in the mathematics model.
Well, what people usually do is, there are some people who consider models with having, for instance, the sea on one side of the city. So there we would have a hole because you cannot locate people on the sea. So you would consider just maybe half of the space to locate people, but putting really holes in. I didn't see many models, any models doing this. Yeah.
No, there are models of what we call leapfrog development, but you have to add some other reason for the agents to do such such gap in the development. But with both assumptions, it's not really ethical, because here it's really come from the dynamics, and that's what the simulation adds to the analytic model.
Yeah. Actually, the next model we are looking at will have some holes, but it's not standard in economics. It's more a work of geographers, let's say. So you will see how they can arise in those models. Other questions? No. Okay, so let us move on to the next model we study. Okay, so the next model we study is also based on the same urban economic framework, but it is an open city model. So this time you will have a city growing from nothing, and it focuses really on the study of urban forms and how they grow from as the city grows. So just very quickly some vocabulary from economics, I guess, mostly. So there are features of the city which we haven't really studied yet. Well, you saw maybe in the previous model that there was a possibility to add an amenity. So yeah, some people explain the fact that, for instance, in the European cities, you tend to have a rich center and a poor periphery. By the fact that the city center is usually a historical, nice center, and it attracts maybe some people more than others. And that's what people call, for instance, a positive amenity. So an amenity is a feature which increases attractiveness, especially of a piece of real estate or geographic location. So something which would be reflected in prices, for instance. And for example, they give the usual ones are having your housing next to a park, or having a view on the sea, a nice climate, etc. These are all amenities. And the contrary would be a disamenity, which is sometimes used also. And the economics makes also a large use of this other notion of externality. So which is in a model a cost or benefit which affects someone who did not choose it. For instance, the classical example would be air pollution. So if you are commuting from far away to the city center by car, for instance, you generate a lot of air pollution, but you are not paying for it. And actually, this is the standard answer of economists to any problem. It's an economic answer, of course. So yeah, if you have too much air pollution, you just have to internalize the externality. So you have to make people pay for what they generate. So that's you have heard of carbon tax prices, etc. So this is the whole idea. So internalizing in the system the externalities. So whatever cost you are generating, you should pay it yourself. Well, there may be also other solutions to those problems, but these are the ones proposed in economics. For instance, Miriam Schindler, who works with Geoffrey Caruso, did a whole PhD thesis on those aspects of linking this kind of model with air pollution. Okay, so we will now study this other model which focuses on the study of urban forms. It's called SGHOST for self-generating housing, open space, and transportation. So it's not anymore an agent-based model, it's a cellular automaton, sorry. So it's the agent-based without the agents, if you want. And so it models the growth of an open city, including the road network. So far, if you noticed in the models, we were supposing that it was easy to commute from anywhere just radially without any roads. So roads were not taking any space. But now we will have roads in this model. And this makes it quite more complicated. And so cells have three possible states: residential in black, road in white, and agriculture in green. And so space is converted over time, and the development conversion, so cells becoming roads or residential, are irreversible. So you cannot go back once a cell has been converted to road or residential. It stays like this until the end. Okay. There's a public agent which creates roads based on a residential domain. So the whole point of the model is to locate based on a utility function which we will describe shortly after, to locate people, and then roads are created to link the residential locations to the road network. Okay, so I describe this a bit more in the next slide. So I introduced amenities because this model makes an important use of those notions. So it introduces two types of amenities. So green amenities, the same as what I described before. So having a park nearby your agricultural space can be a benefit for your housing. You like it more because you have a view on a green area. And also social ones. So there can be a happiness, a welfare linked to the fact that you have a high density around you, maybe lots of services, etc. And so in this model, these amenities, they depend on the density, the density of residential cells computed in a given neighborhood around a given cell. So you are in a given cell in this environment, which is also in this two-dimensional grid, and then you compute the density of residential cells in a given neighborhood. So the radius R hat is one parameter, the radius of this neighborhood. Yeah, and then so this density rho will be included in the density in the utility function. So this function which you have here is exactly the same as the one we have been looking at since this morning, except for the two last terms. We didn't have them, minus delta rho and plus gamma square root of rho. We didn't have them until now, but they really represent these green amenities. So green amenities minus delta rho, they decrease with when density increases. So the more residential cells around you, the less green, and the less you are happy about having green around you, of course, because you have less of it. And delta is then one parameter which is additional to this to the previous model to describe this green amenity, and the same for the social amenity. So there's one parameter gamma times the square root of rho, this one. So something increasing, the more the residential density around you, the more you can benefit from this social amenity. The fact that many services and social networks, etc. might be, the more access you have to many people around you, etc. And we will really study the influence of those two new parameters on the outcomes of this model. So what happens at each time step is then that one agent moves in the city, and this agent chooses the agricultural cell which gives him the highest utility. So he can choose any of the green cells you see in this grid, and chooses the one with highest utility, and then the road network is connected to his residential location. Which just I didn't mention the routes, but they are just a minimal link to the existing road network. And I thought I was saying that. Oh yeah, you start from two pre-existing orthogonal roads. So this white cross, which you see there, is a starting point of the model. So you suppose you have a crossing of roads, and this will generate a city. Okay, so I think I also put on Moodle the paper and the model then. So what we will do with this model is mainly to look at the two new parameters which we have added since everything we have presented before. So this delta and rho, preference for green amenities and preference for social amenities. And we still have also the neighborhood radius, which might also change the results. So yeah, you had two parameters to explore before, now you have three. So what I propose you to do, since we already saw that with 3 parameters you have already a very high number of simulations to perform, so what I propose you to do is to just follow, for instance, those 3 types of simulations. So it's more or less a comparative statics or sensitivity analysis. So you change just 1 parameter at a time. And those are the ones which are done in the paper. So if you want to have a look at it and understand a bit more, well, you won't have really time now, but later it's possible to compare with the paper. So it's a Java model which is linked also in Moodle. I propose that you download it and try to run it and changing those parameter values. Any questions about the model? No? You have to open the jar file. And then you can change parameters,
Tu n'as pas de minimum, pas de maximum. C'est censé être exemplaire. C'est les gens de ça. Et ce genre de France, c'est pour les espaces. Vous pouvez les changer maintenant? Ouais. Dans un premier temps. Une de là. Non, une de non, tu prépares une fois, et puis après tu testes, et après tu vas faire un test, etc. Comme ça, tu vois les gens.
Ouais, j'ai fait.
Toi, j'ai dit 50%.
Non, j'ai pas mis les chiffres.
Mais tu fais capable de. J'ai mis 0,5. Tu passerais cette. Tout à l'heure, j'ai eu combien? Il y a 0,25% qui est
ah non, oui, il faut ouais. Non, j'ai pas mis ça. Après, c'était
non, par contre, j'ai choisi c'était 0, 0, 0. Ah, ok. C'est ça que j'ai vu. D'accord, c'est quelque chose qui se voit à l'échelle, se voit avec d'autres choses. Par exemple, la Tour Eiffel, elle se voit à l'échelle du quartier, à l'échelle de Paris.
Mais ça veut dire quoi, c'est
tu vois, là, tu prends ça. Donc ça, si je fais 25% d'habitation, 50% de titularisation. Et attends, comment tu l'as fait? C'est la retrouve que pas cette année.
Sur la première période.
Il y en a une.
Voilà.
Ouais, c'est ça.
Je sais pas si c'est je crois qu'il y en a une. Non, elle est en bas. J'ai essayé de vérifier.
Tu sais que c'est plus de minutes, ça
Est-ce que ça va marcher? J'ai mis 8 ans et 8. Ça marche si je vais mettre ça. Ça
c'est
ça va pas. Ouais, ça veut dire que il n'y a pas de dérogations, ça l'envoie de ils sont d'accord, c'est ça. C'est pour les scientifiques,
moi, c'est une préférence militaire de 1, c'est-à-dire qu'il n'y a pas ouais, mais tu vois, avec les combinaisons de carré. Et si je mets.
C'est quand tu fais.
Ça sera plus long aussi parce qu'il y a la différence.
Quand tu lis une décharge électrique dans solide gratuite après solide, si tu fais des placards,
Distillé, ouais.
c'est une forme similaire après, et il y a rien à passer sur ce modèle-là.
Tant qu'il y a une espèce,
C'est pour ça que je suis pas sûr à 100%. Mais entre les similarités au niveau de ce modèle-là et les différents placards. Après, les similarités malgré tout. L'électricité, le fait que ça certaines branches, c'est aussi lié à l'électricité à chaque fois. Ouais, tu peux passer. Il y a ce potentiel électrique, longtemps que j'ai mais si tu vas savoir, il y a le potentiel électrique et tu peux chaque fois dans les options, ça change un peu plus. Et ici, il y a un peu le même, à savoir que les grands sont à chaque fois
j'ai remodifié plein de trucs uniquement la grille conférence.
En fait, là, ce qu'on a ajouté par rapport au modèle qu'on avait avant, c'est un peu plus.
Là, 0,2,
Là, on a ajouté des externalités.
voilà.
Et si tu veux, tu as l'externalité sociale favorisée dans cette échelle. Ça, l'externalité, ça a tendance à plutôt être une sorte de répulsion à la danse.
C'est un truc comme ça, ouais.
Et du coup, ce qu'on perd, c'est l'arbitrage entre ces deux.
0,2, il va faire ça.
Qui passe pas directement.
Voilà.
C'est la dans sociale, c'est extrait.
Je me dis avec eux, je vais un petit malaise entre les gens.
Les gens, ils s'en foutent pas. Ouais, bon, ils sont carrés.
Il a passé la France, non? Je comprends pas, moi.
Et sur le modèle,
alors, c'est pas bizarre. 5 minutes plus tard. Et donc, ça devient un peu polish.
Ouais. Non, bah, ça c'est le cas et c'est quand même. Après, tu peux l'estimer du coup avec le bien.
Ça change rien, je crois. Le fumer à droite.
Plus qu'à rédiger, c'est bon.
Ça ressemble plus à ça.
Mais qui n'est pas le plus.
Mais
Ça, c'est
faire
genre.
que mon gauche, ça suffit. Ouais, justement. Regardez.
Quelqu'un là-bas, il a fait penser que ça fait un peu planter la tête.
Ah ouais? Ça, j'essaie de tout n'importe quoi.
Comment? Ah ok, on est d'accord.
Ok, donc on va pas être distant.
C'est la première fois. Il y a un endroit où on peut mettre l'homme à la fin.
Ok. Ouais, c'est vrai.
Le modèle est déjà là.
Ouais, ouais. C'est dur. Donc on est là, c'est juste pour
On avait dit qu'on allait s'occuper.
déjà avoir un peu. Bah, donc, on a trop de toute façon, on n'a pas le temps. D'accord, on comprend rien, non? On comprend rien du tout. C'est chiant. Il est à quelle Timothée?
En fait, t'as si tu choisis. En fait, t'as.
Oui, ok, d'accord.
Ça veut dire qu'ils sont pas dans les paradis.
C'est dans l'exclusion.
Surtout maintenant, on a une idée.
C'est dense que ça.
C'est bien, ça c'est bon.
Tu peux la suivre. C'est ça, tu peux la suivre toute seule dans la main. C'est qui à toi?
Ah ouais.
C'est toujours.
J'ai entendu des conversations
Il a fait
super
venir,
violentes.
c'est avant.
Ah ouais? Ah oui, oui. Non, mais en vrai, j'ai dit pas de
En fait, en gros, tu t'as eu d'avoir un problème sur le monde.
Je t'ai mis un. Toi, t'as changé.
C'est pas moi, ce n'est pas.
Alors, en tout cas, si c'est pas dépendant d'un autre.
En gros, c'est lors de c'est pas un lien d'accord avec le gars. Et ça,
Attends, le delta, c'est une même valeur.
Beaucoup ça se rapproche de.
Donc en fait, là, donc
Plus ça se rapproche
qui est plus
de 1, plus ça se l'indice de la société. C'est bon, c'est même pas tant.
non, mais en gros, c'est pas
Ok, et donc, si je mets 0,5 ça veut dire que ça aura être en sans population.
Mais intensément, plus intensément que.
Donc en fait, sauf qu'en fait, c'est bizarre de trouver une référence d'activité. Non mais je sais, mais finalement, ils sont finalement bien.
dans la figure.
Oui. il faut bien que tu définis des valeurs qui sont pas en lien, mais après tu les mets en lien pour pouvoir faire la figure finale.
C'est ça, techniquement, si tu as pris cette là, tu auras tendance à pas.
Ah ouais?
Oui, d'accord, mais sauf que pas faire gaffe, parce que voilà, c'est 0,7. Donc en fait, les gens, en théorie, il ne faut pas avoir d'espèce là, il doit être complet. Et comment il est. Oui, mais c'est ça, je comprends que ça fasse ça, mais alors comment ça se fait qu'il détermine que là, t'as des espaces où les gens peuvent. En fait, il prend les. Après, si c'était sur 100, ce serait les 20% qui restent. qui tiennent la nature.
Non, c'est pas tu passes ça sur 80%, 80%. Limite, c'est stochastique. Alors, je suis sûre que sur le commun, tu vas avoir une figure.
C'est à 0,5.
Ah bon?
Ah ouais.
Non, bah, c'est pas pareil. Ah ouais,
C'est la même, hein. Oui, après la même, c'est ça le problème.
regarde cette image.
Tu peux appuyer sur OK à la gauche.
Non, mais
En fait, on lui a donné un coup de méthode.
Ouais. À chaque fois,
Est-ce que les valeurs elles sont bornées? Les variables sont bornées.
après, on peut monter les valeurs.
Je crois qu'après, il y a le modèle qui plante. Bah, je sais pas. Ce qui est bizarre, c'est qu'en fait, genre, tu vois, quand tu mets 0,7 pour les gens qui aiment mieux la ville que la végétation, tu te retrouves quand même à avoir ça, tu vois. C'est bizarre. Je comprends pas. Donc j'ai mis 0,5.
Il y a quand même une possibilité d'avoir un modèle. Parce que ça je l'ai eu avec les canevas, mais j'en ai eu plusieurs d'autres modèles où c'était symétrique.
Tu touches au troisième degré? Non, moi je sais pas trop, j'ai pas eu des trucs
Je comprends pas la spécialisation. Pourquoi je vais avoir quelque chose de
Moi, je sais pas pourquoi. Là, je vais 0,7. Et 0,7 pour la partie de faire appartenir à une zone habitée. Et j'ai mis 0,5 pour la partie végétation. Et à quel moment c'est une situation de variable?
il y en a une des deux qui est moins bonne que l'autre, c'est celle qui est linéaire, la racine carrée, ça va moins vite que linéaire. Mais sinon, c'est pas bien faire les deux paramètres vont donner prépondérance à l'homonomie, mais les deux sont additifs, parce qu'on additionne du mélange. Il y a des corrélations qui sont intégrées. L'agent choisit.
Et le classique, elles sont bornées. C'est pas qu'en gros, est-ce que là on a une variable max?
Je crois que
les valeurs que j'ai utilisées, c'est souvent des trucs assez faibles, genre détail, quel 2, 3, en max, c'est paramètres. Pour celui-là, par contre, c'est bon, je pense que c'est fait les calculs plus loin. Mais pour les deux-là, c'est assez pas sûr.
Ouais,
je sais pas si je vais dire ce que tu veux.
En fait, en gros, j'ai du mal à comprendre pourquoi, genre, avec 0, en fait, au début, je voyais ça en termes de pourcentage d'espèces.
C'est vraiment les valeurs qui sont paramètres.
Ouais. Ouais, c'est pourquoi je mets 0,7. Ça me laisse le calcul. Mais en fait, j'ai pas beaucoup de temps, en fait, il y a quand même tout ça qui est plus, bah, il est plus attiré vers la végétation aussi.
Ah, il y a peut-être une chose aussi que j'ai pas dit. Ce que je veux dire, c'est que quand il y a des exécutifs entre différentes cellules, ils choisissent au hasard. Donc du coup, c'est ça qui fait que par exemple, c'est parti dans ce sens-là, et c'est parti dans l'autre sens, parce qu'on va attaquer des quatre. Et après, le mécanisme de base, à part ces exécutifs qui peuvent te donner casser la cerveau, pour partir dans un sens, ben, c'est vraiment on choisit la meilleure série. Alors après, il y a là, je dérange comme ça, et qu'il n'y a personne qui met sur localisation là. Non, c'est ça. C'est que quand quelqu'un choisit une série pour la relier au réseau, donc du coup, où est-ce que je le relierai ici? C'est quoi comment ça change pas? Là, il n'y a rien en fait. C'est d'autant plus sur les disponibles. Nous, ça fait déjà c'est super long, il y a personne qui va le faire parce que c'est pour ça qu'après les gens vont plus se mettre. Ah oui, il y a toujours à la base, même si c'est moderne, la même utilité, fonctionnalité, on a juste rajouté des préférences pour le vert et pour le social. Mais sinon, c'est le même modèle de base.
Des cellules. Par exemple, il y a une cellule qui est déjà destinée à la maison parce qu'elle est traitée en première. Comme disant une station ne pourrait pas s'installer ici parce qu'une maison déjà ici, on ne pourrait pas casser les routes, faire une route. Bah, ça fait en sorte que du coup, il y a une idée dans l'ordre de traitement des cellules.
Maintenant, on les regarde vraiment toutes à la fois et on choisit celle qui donne l'utilité, le bien-être maximum, l'utilité maximum. Donc elles sont vraiment toutes regardées en même temps, il n'y a pas de vie. D'accord. C'est important.
Oui, en fait, je voulais savoir s'il y avait une raison particulière. Toi, ici, par exemple, on va avoir une densité plus importante qu'ici.
Ici, il y a tous les algorithmes pour savoir
Ici, on va avoir une amplitude plus en gros, et ici, on va avoir une amplitude. Est-ce qu'il y a des particulières? Ouais, non, mais voilà, c'est question pourquoi on va avoir une densité genre ici.
Pourquoi la première densité, tu veux une densité? Je suis pas sûr, là, les gens qui sont peut-être pas la seule
Et pareil, je pense qu'il y a beaucoup de symétrie. Oui, le modèle en fait, il est déterminé justement à part quand il y a des exécutions, on choisit toujours la cellule qui est dans l'exécution, c'est toujours la cellule de l'utilité maximale. Quand
il y a des exécutions au hasard, là c'est cassé aussi, si tu dessines, c'est
Okay, let us conclude on this also. Okay, so what can someone try to? Can someone first explain why, if you choose 0 for both parameters, I hope you all try this. You choose 0 for gamma and for delta. Then what you obtain is not the same model as the one we had before. You just see a cross. A black cross on each side of the white cross. You all have seen that, I guess. Can you explain why? Why you don't see the circle we had before? The disk. Sorry?
They follow the road.
Yeah, they follow the roads. So, and why don't they locate in the quadrants? What's the problem?
There are no roads, not a road to link between the principal roads.
Yeah, exactly. So the residential locations are blocking access to the roads. So actually, if you want to locate outside of these main access points, you have to do a big detour to go to the city center, and this is really bad economically. So there's always the same economic model with commuting, etc. So people end up going just along the roads. But as you could see, I hope when you change parameters, you change also this result. So what happens, for instance, when you increase delta, the preference for green amenities? For the people who did the first experiment, for instance, what happens? So at some point, when you increase delta from 0 to something higher, you see other forms. The city size is decreasing, yeah, that's true. Do you know why? Sorry?
Because the green areas is more than the delta area.
Well, actually, it's really linked to something you are adding in the city. So if you are keeping, you forget this one, you are just increasing this delta here. So you are decreasing this utility. And if you haven't changed the parameter utility of the rest of the world, you are decreasing utility. What happens in the open city model? What happens for the population size and for the city size in the following? You decrease it. So it's really this which happens. This is an open city model that's following everything we said this morning. So that's why. But focusing more on urban forms, what happens then when you change delta?
Houses are more separated.
They are more separated. Yeah, so you see forms looking like fingers, which appear everywhere. So the kind of development you see, at least, has a lot of holes, of green holes, because people want to be located close to green. That's the main idea. So there are people who want to move away from the two principal roads because they have this preference for green, and then other people will want to avoid the first ones, and you see these kind of fingers going in every direction, which appear. Okay, what happens when you, in the second case, for instance, when you change gamma, so you increase the preference for social amenities? What's the influence, the very broad influence of this parameter? The city is very dense, you say something? Yeah? Yeah. Yeah, the city has a very compact form. It's really, everything is filled. So you increase the preference for social ties and having lots of people around you. So yeah, you tend to fill in everything in the city. Okay, so and of course you can have all varieties between those. Which when you change both parameters simultaneously, you can have everything in between those fingers and those very compact forms, etc. And then have you changed also the neighborhood radius? What happens with this? No? Well, I will say so when you change the neighborhood radius, at least with these parameters, you see when you increase the neighborhood radius, you see that you see the same patterns but kind of zoomed in. So as the neighborhoods grow in size, sorry, you have the same patterns but really growing larger also in size because the people are more affected by cells which are further away. So that's the main influence of this parameter. Okay, we saw very different urban forms on all your screens. So you see that already with just 3 parameters you can go in every direction and get lost. I guess I saw quite many people who seem to be lost in this parameter space. So that's one more lesson to remember from this. Are there some questions about this model? No? Okay, so I think I will give back the floor to Justin, who will now present the next model you will see now.
Yeah, that's the last part of this presentation. So now we'll have a look at multicentric cities, so cities with multiple job centers, because in all the model that we have seen previously, we have been relying on the seminal assumption of von Thunen, which was the isolated urban state, and one of the underlying assumption is the assumption of monocentricity, that jobs are concentrated in a single point. Okay, so there are some problems with this assumption. First, from a purely theoretical perspective, it's not really satisfactory to have to assume that jobs are concentrated in a point, because this point is the generator of all the gradients that we may have in our model. So in a sense, spatially, everything is relying in that assumption. So we would like to explain the existence of such a concentration of job. And also, from an empirical perspective, well, cities are less and less monocentric. You can see, so in the literature, it's about America, but also in Europe, you can see that sub-centers are created and they are taking people out of the old previous urban centers. So from both theoretical and empirical perspective, this assumption of monocentricity is not completely satisfactory. Okay, so there are many reasons why people would want to agglomerate. There are social reasons, historical reasons, cultural reasons, but here we will remain in the framework of urban economics, and so we will focus on the reason why economic activities will agglomerate, will create clusters. So actually, I will carry on with the topic of this afternoon, because the answer to that question is positive externalities. Again, there are reasons why businesses want to locate close to each other and that are not growing through exchanges on the market. So there is a huge literature in urban economics about that topics. Here I will show you the classification that were proposed by Duranton and Puga, but very often people are talking about agglomeration economies, so the benefits that an economic activity may have by staying close to other businesses. Okay, our first reason is sharing. So people, or I would say businesses that agglomerate in a point will share some stuff. It can be many different things, but the most representative example is indivisible facilities. For example, business activities need, I don't know, electricity. So you need to build a power plant. You can build your power plant everywhere, but of course you cannot build several power plants, like every village having his own power plant. It would be much too costly. So by agglomerating, businesses may share this kind of indivisible facilities, so it's not exactly indivisible, but multiplying them would be much more costly. So sharing is the first reason why businesses would want to agglomerate together. Another reason is matching, and the most bright example is matching between job offers and job demand. So people can more easily get a job in cities, and also, so that's the chance aspect, but there is also a quality aspect, so that you are more likely to find a job that really corresponds to your profile in a city, because there are more diverse offer than if you stay in the rural neighborhood of the city. Okay, and the third one is the most important regarding cities. It's learning. People learn from each other, from having interaction for different kind of activities, and there are three main processes. Oh, sorry. We call the first kind of externalities, of learning externalities, is called MAR for Marshall, Arrow, and Romer. So those are three economists, and they assume that businesses, when they cluster, they tend to learn because they interact with businesses of the same industry. So that was the first old explanation by Marshall. Then another explanation was provided by Porter, who say, okay, being located close to other businesses from the same industry is something that will push me to learn, but because I'm in concurrency with them. Okay, so it's more a pressure to innovation that generates knowledge in cities. And the last one, maybe it's the most known among geographers, it's Jacobsian externalities. So Jane Jacobs postulates that what makes people learning so much in cities is diversity. I learn from being with people from different industries, and actually the argument of Jacobs was not only about economics, but it was also more social. I learn by interacting with people from another social context and all that kind of thing. Okay, so those are the main agglomeration economies you may find in the literature, and actually they are divided in two classes. So the two first one are considered, you cannot read it exactly, I guess, but the two first one I call localization economies, and the third one is really called urbanization economies. So I just want to say it in order to emphasize that really when we think about cities, agglomeration economies is essentially about learning. Okay, this is a theoretical division, but you may also notice that in the empiric literature we have found more evidence of learning externalities in cities than at a regional scale. Okay, so there is also a spatial scale associated to this subdivision. Okay, so now what we want to do is to go back to the previous simple monocentric model of Alonso, but we will introduce those learning externalities between businesses in order to endogenize the central business district. Okay, so this adaptation is the model of Fujita and Ogawa, and actually in some sense, on some aspects it's more simple than the Alonso model, but on some others of course it won't be. So the main difference is that the land, so the consumption of the housing consumption is now fixed. And we will have businesses, and for the businesses also, the consumption of land is fixed. But now the problem is the wage. Because since the households, they are not going to work at the same place, they will have different wages. And so we will have to say how households and businesses negotiate wage levels. Okay, so I will represent households by a house. Okay, sounds logical. The utility function is now reduced, so there is no substitution effect like in the Alonso model. The utility is just reduced to the consumption of this composite commodity, and so it's equal to the wage minus the transport cost minus what I will pay for the rent, with the, again, housing consumption being fixed. That's for the household. But now we also have businesses, and to model businesses, we don't use a utility function, we use a profit function, like for the farmers in the Fontunen model. And what we have is the benefits of the business. I will come back to the meaning of this f function later. So the benefits minus the cost. What are the costs of the business? Well, LB is the number of workers that the business is hiring, times the wage, of course, and minus what the business has to pay for staying in a place, so the fixed consumption of space times the rent. Okay, so it's quite, it's not, well, it's quite intuitive, I would say. The only thing that may look strange is the benefits of the business. It's a constant, K, time what we call the locational potential function. And actually, this locational potential function is the way we will introduce agglomeration economies. We will introduce them in a very broad way. That is, this locational potential is simply the sum of, over the entire urban agglomeration of the density of businesses. So you can consider B as being the number of business at X, multiplied by an exponential distance decay. Okay, so it's a kind of spatially weighted mean. Okay, that represents the fact that when I'm closer to other businesses, I will get more productivity from them than from businesses that are located further away. Okay, so this is a general form. We may discuss the fact that it can be deduced from an optimal decision of face-to-face contact, but this is not an important part of the literature. So for now, just consider that you have this locational potential, and that's very important because that's what's going to represent the agglomeration economies in our model. Okay, but now, as I said, the challenge is about wages, because in the previous models that we have seen today, everything was driven from a spatial perspective by the existence of this central business district. But here, we have a direct relationship between households and businesses. Some households will be related to some businesses because they will work for them, but maybe my neighbor is working for another business. But we are still competing for the land at the same place, or approximately at the same space. And this competition will be at the heart of the model of Fujita and Ogawa, and you will see that we will need some other tools in order to solve this model. And really, the link between them, as you can see in the equation, is about the wage. Okay, so the wage that I'm giving here is the way that is perceived by the household over there. Okay. Okay, so now if you consider the monocentric configuration again, what you have is now in blue a central business district with businesses inside, and you have the outer ring, which is the residential area. Okay, so once again, it's quite close to the circular configurations of Fontunen, but here we are going to do it the other way around. We start from the configuration and then we will infer the B-drain function. Because at that point, the problem is that I don't know, for example, yes, hello please. If a household is working here, then I don't know whether his boss, the business he is working for, maybe it's here, maybe it's here, maybe it's here, but it will change many things, okay? Because the net income won't be the same, because the commuting distance won't be the same, okay? So we have to find a way to match businesses with households. Okay, how did Fujita and Ogawa solve this problem? Well, actually, they realized that at the equilibrium, there are some commuting patterns that are not possible. And typically, they cannot be cross-commuting. Here is the mathematical expression, but to illustrate this, consider these three examples of commuting patterns. So A and B are residential locations, agents, households, for example, and I and J are businesses. And households A is working for business I, and households B is working for business J, okay? Actually, those three patterns are not possible, okay? Simply because for each of them, you can switch A and B so that at least one of them fits better afterwards, so that it could be reached using some political adjustments, etc. So providing that there cannot be any cross-commuting pattern in the city, necessarily at the equilibrium, we only have radial commuting that are not overlapping. So here I show you some commuting lines, and as you can see, let's try green. Someone that is located at the border of the city will commute to a business that is located at the border of the business, okay? And another household located more closer to the central business district will work for a business that is closer to the central of, also to the central pole of the central business district, okay? Okay, so basically, once that you have that relationship between households and businesses, now you can solve your model, because we have the commuting distance, so we can compute the commuting costs, etc. So we can compute the bid rent, and then it looks like this. So for businesses, now I will start by household. For households, there is nothing really new, okay? We have a bid rent that, like the von Thunen model, is decreasing linearly with distance from the city center. But for businesses in blue, so it's represented by the Greek letter phi, it's much more interesting. You have, of course, the bid rent is very high in the city center, because I like to be close to other businesses that also are in the city center, and then it will decrease quickly, because if I'm locating in the residential area, then I'm really going far and far away from the other businesses, so my productivity will go down, and by this way,